Hello and welcome back to Barkerways. This is a real-time example of something that's come into the workshop and it's been a bit of a challenge to fix. So, been doing boxers since the 80s, so we're pretty good at these. This is a car that's been recently purchased by the current client, hasn't really driven it very much, and it came to us for, he struggled to start it and it had some oil leaks, so we did a full report on the car. So following on from that, we've had the engine out, we've done lots of oil leaks. There was done the cambelts, cam drive bearings, cam covers, tappets, so there's a lot of mechanical stuff that's gone on. Engine's all back in, got it all back together. So when it came to test driving it, it still didn't start too well, and it had a strange intermittent misfire. As soon as we went down the bypass, it was da-da-da-da-da-da-da-da-da and very intermittent. So I want to walk you through some of the things that we found and how hard it is to diagnose and get the right parts to fix these cars. So before we do any diagnosis, you've got to know what good looks like. So what I thought I'd do is just run up a little test rig here to show you how a basic ignition system works. So what I've got here, I've got a battery, which the car's got. I've got a distributor, which does what it says on the tin. It distributes the spark to the right cylinder. And I've got an ignition coil and some makeshift connector leads. What's going to happen is the distributor tells the coil when to fire. And as that goes round, you can see the voltage. And now this is thousands and thousands of volts. So you can see that's jumping about a 10 mil gap very easily. So all the time it's going round, it's triggering a spark. Now, but if I move it away, you can hear it still sparking, but what that's doing is shorting inside the coil and going somewhere else. Electricity will always take the easiest route. And if it can't go down the easiest route, it'll go somewhere else. And if it goes to the wrong plug, you'll end up with a misfiring cylinder. So the key to knowing where the spark goes is getting it to where it needs to be. So hopefully that's shown you sort of how we generate the spark. So we've got a distributor that is engine driven going round with either an electronic module or contact points in there that open and close that basically turn on and off the power to the coil. This is an oil filled ignition coil, so it's two windings. There's primary and secondary windings. And when you collapse the primary windings, the secondary windings basically send a big spark out the top. So by turning these on and off, it generates a magnetised spark out the top, which you've just seen is thousands of volts. So the next bit is we've generated the voltage, we then got to send it to the spark plug at the exact time the piston's coming up, ready to be fired. So then you've got what's called the distributor. So, and on top of the distributor, you've got a distributor cap. So in here, each one of these is connected to a plug lead that we've got here, which then will go down to the spark plug. And in the middle of this going round, this rotor arm here will go round and it'll line up with each one of these pointers. So what you need is as the rotor arm comes round and lines up with the pointer, the spark is generated over here, it comes through the rotor arm and sends it down that plug lead to that plug. So that's how it gets to the spark plug. Now, if you've got a misfiring engine, something's going wrong. It's either getting to the wrong spark, it's not getting enough spark, or, as we've just shown, if you've got too much resistance in the leads or in here, it'll go somewhere else. It'll go to an easier route, and therefore that cylinder won't fire. It's hard enough diagnosing these things in the first place, but when you've got multiple faults, as this car had, it's been a real challenge. So, we've moved our distributor out of the way. Something we found first was one of the wires that goes to the coil ignition system. It looked like it had been soldered and it was all soldered up, but when you actually look at the end, there was only about 3 strands of wire actually making any contact. So there wasn't enough current going through the wire to make the system work. Electricity is a bit like water. You need electricity to flow, and if you've got a thin pipe, it's not going to flow. If you've got a big pipe, and it's the same with wire. If you've got a thick wire, you'll get flow. If you've got thin wire, so if you only got about 2 strands, you're not going to get a good trigger. So the system's failing before it even starts. So that was our first thing we found. Then this was a real red herring. It's very rarely you come across this. Distributor caps are made of like a Bakelite material, and they're made of that because the insulation, you've already seen, you've got thousands of volts, 8,000 volts going through these things, and the spark needs to go down to the right place. It can't go arcing across to the wrong place because you get a misfire. So what we found on this Bakelite somehow has gone porous, and the way we found that, if I get my voltmeter out, what we were doing was checking the resistance between the contact and the end of the lead, But what we found that you had contact between different parts of the distributor, which shouldn't happen. So this is an isolated insulated connection that goes from there to the spark plug. It doesn't want to go to the one next door. So if I was connecting my ohm meter here and ohm meter here, I was getting a reading for a plug that was 2 plugs away. So clearly whatever was going down this plug being distributed was then getting shared with other plugs. So you can imagine the sort of intermittent misfire that was causing. So we thought, right, we found that. We've now found 2 problems. We've got a weak trigger in the whole system and a bit of a random spark system. And you can see by the little video I've done that it was actually coming out through the cap, through the fixing nut for the distributor cap and going to earth, because it was easier to go that route than it was to go down the spark plug. So I thought, great, we found that, we're off to the races. So on went the new distributor caps. I thought, right, that's covered distributor caps, we're done. Went down the road, still got misfires. So we thought, okay, plug leads. Let's talk about plug leads. So there's basically 3 different types, or 2 main types. These are insulated cables that have got to transfer thousands of volts through a length of wire from the distributor down to the spark plug. And all the older cars had what's called copper core plug leads, which is basically a copper wire in an insulated rubber tube, or a sort of stainless. Some had stainless on. The later cars had what's called a carbon brush, so it's a carbon lead that's insulated through. Now, on the earlier cars, you've got a 4-cylinder engine. It's sort of pulsing, pulse, and it can send the electricity down the lead, and it can go to the right spark plug, and it's fine. When you've got the later electronic ignition systems, the pulses are bigger, and it gets faster. And we've got a V12 here, so you can imagine we've got 1 coil firing 12 cylinders. So this is happening, so many times a second at say 3,000 revs. This is really buzzing, and what you get is the copper leads can't conduct it fast enough. By the time one trigger's gone down, the next one's already behind it, and you get sort of bounce back and things and misfires, whereas the carbon leads are much better at transferring the digital signal rather than the analog signal, and they're more durable. And the other thing, when you've got a bunch of plug leads like this, it's all bunched together, and you've got all these signals going down different plug leads at different times to different cylinders. On the old copper leads, you can get what's called crossfire, that it's all happening so fast it'll start to come through the insulation and go to another lead, and they'll start to crossfire and fire the wrong cylinder rather than one they're supposed to, whereas the carbon leads are much more durable for that. So all electronic ignition cars have carbon leads. So we thought, great, put some leads on, put a set of leads on, went up the road. It was worse than the ones we'd just taken off. So we thought, great. And this is something we come up with just because everything's new doesn't mean to say it works. So we checked all the leads, checked all the resistances, got another set of leads, and then we found we had a consistent spark. So we can't assume, even though we've spent a long time diagnosing this stuff, that the stuff you fit is any better than what you've taken off. So we looked at the leads. I thought, right, there's got to be a reason for this. So when I've looked at the leads, and I'm sure the manufacturer's got an idea on this, when I look down the inside, when you've got this carbon wire, if it's just cut, you've got to join the carbon wire to the brass end that it's connected to where it goes in the distributor cap. And when we make them, we usually bend them over. What these have got is that there's a tiny little stainless steel wire going around the carbon, and it is tiny, and that's bent round. And I was thinking, can you get thousands and thousands of volts? A bit like my water thing. You've got to have a reasonable sized cable to get through, and it's the tiniest of wires. When we looked at the original leads, they had a big sort of like clip dug down the middle of the lead and then came out and joined the middle of the lead to the outer connection, which I thought was a much better idea. Okay, so as well as our plug leads, our spark plugs and everything else and rotor arms, we've got these little things. Now these are Bakelite, because the spark plug's on a boxer, a recess down in the head, which is basically a hot tube. So if you put a plug lead down there with a rubber top, it's going to get really hot and it's going to fall apart fairly quickly. So what you do is you put a little, basically a spacer on it, a little Bakelite spacer, so the Bakelite is more resistant to the heat in the tube and the plug lead stays outside. Now, when we looked at these, because these are quite prone for breaking down, these are fitted to 308s, boxers mainly, and because they live in the hot environment, they do tend to warp and crack, and it's usually the first place you go to when you get a misfire. The ones we can buy now, this is an original one, it's a different Bakelite, and when we looked on Ferrari, you can't get these anymore. It says on the website that you can have them till they've run out. When they run out, it supersedes to another part number, which is this one. And you can see it's a slightly different material. It's a remade product. But when we put our ohm meter on it, so the original ones, I've got two originals here. We've got red ones and black ones. So the black ones, original, have got a 15 ohm resistance. The original red ones have got no ohm resistance, or 0.2, and the new remanufactured ones have got 4.5 to 5 ohms resistance. So straight away, we can't buy one of those. We have to have one of these, and it's got a different resistance to the original setup. So not the end of the world, but again, I haven't got anything else to work with, so you've got to go with it. So we fitted a new set of these as well. So we're now thinking, crikey, we found incorrect leads, porous distributor cap, low current cable, different ohmages, plug extensions. No, any other car you'd have fixed this by now. We're still going down the road, and we've got an intermittent, but we're getting there. It is better. So obviously the other thing a car needs to run on is fuel, because this car ran beautifully. We now got it to start better. It's starting to run better. So we're looking at the fuel. So we did all the COs. We managed to get the hydrocarbons down to sort of under 1,000. They were sort of 500, which is spectacular on a Boxer. And we also did something called the air-fuel ratio. So what we can do is go down the road with basically a pipe up the exhaust, and we can read the airflow ratio as we're driving the car. So you get real time, a bit like a rolling road, you can get real time data of what's coming out the exhaust. So the 2 meters we do it, and we were pretty bang on. So what was coming out the exhaust was pretty good. So therefore carburetor jetting, things like that would seem to be in order. So we've sort of, gut feeling is the fueling's right. So what's next? So the next thing is electronic ignition module. On Boxers, they used to have what was called a Dinoplex system. Now this car had this replaced. Now they've caused problems before, and they can cause all sorts of chaos. What this car had on was a black box that we had no knowledge of. We didn't know what it did, what it was, or anything. What we did know, that when we were looking at the distributor timing, as the engine revs up, it advances the timing for you. And we'd had all the distributor apart, done all the bob weights and everything, so we knew the advance curve was right. But what we were getting on the bench was different to what we were getting on the car. So basically, we took this off and we fitted a whole new electronic ignition system to it for how it triggers everything and manages everything. Because what happens, reason it needs one of these, as I said before, on a normal 4-cylinder engine, everything's going around fairly slowly. On a high revving V12, or flat 12 in this case, you can imagine everything's happening a lot quicker. So normal ignition system can't process that much information that quickly. So you have to put an electronic module in to stabilise things and process so many sparks every second. So that's what this does, and clearly it wasn't doing it. So we wired up a whole new one of those, and now it's fixed it. So that's taken we were on this for a week or so doing this. It's taken a lot of head scratching and but to have 1, 2, 3, 4, 5, really 5 or 6 faults on the car, and have some parts that weren't helping either. We had to use 2 sets of some things. You can see why doing this job isn't always as easy as people think. Proof of the pudding is, does this thing start? So we've got all these new components and the right components on it. So starting a cold Boxer, quick bit of Ian knowledge on these. These like a bit of priming to get them going. Yes, they have got a choke, but most of them don't work, but you can get round it. So Ben's inside. If Ben can turn ignition on, we've got our pumps running, and he'll put his foot on the clutch. You always start with the foot on the clutch because it takes the load off the starter motor. And if we give it about 3 or 4 pumps. All right, Ben. And that proves we've got something right. So now we're just checking the oil pressure. Yeah, oil pressure's come up. So this is a stone cold boxer. This hasn't been started today. Where are we? 4 o'clock in the afternoon. So I like to think we've got something right on this car. But the proof's in the pudding. Is going up the road. So let's go and test drive it. So here we are going out the. We're cold going out the yard, and it's feeling lovely. There's no spits, bangs. I've spent a long time balancing, tuning, setting up these carbs, which I didn't go into today because I figured I'd bored you enough with electronic ignition and spark plug leads. So let's, and as I always say, if a car drives well slowly, it's going to be fine. So not quite second yet, so first to third, just get things easing and warming up a little bit. So I mean, this is lovely. Another thing that's a feature of the carburettor cars is what we call the progression stage. So when the car's idling, it's got idle jets, which is why they're called idle jets, and when you're driving, you're on main jets. Now, the progression, exactly what it says on the tin, between the idle jets, which are tiny, and the main jets, which are 5 times the size, you get a little patter or a flutter. So, and it happens about 2000 RPM. Just go gently down the bypass, so I don't know if you can feel it. So we're just coming up on 2 now, and you get a little tiny patter, and that's coming off of the idles, and then it'll go onto the mains, and you can feel the car get stronger. Now, all carburettor cars do that, and you can't fix it. It's just an inherent problem with the car, with the way carb design works. So we're just going down here now, sort of 2000 revs. I must say it's lovely to get a stone cold boxer. So what ignition systems do, as I said, rather than just going a single pulse on a 12 cylinders very quickly, the modern systems, or the more modern systems, do a buzz. So it's more of a multi-spark than a single dot. So it's a controlled spark through to the spark plug, which ultimately gives you a much better burn. If you can set light to the fuel in the best way possible, at the right time, at the right place of the piston, at the right airflow fuel ratio mixture, then that's the best you're going to get out of a carburettor car, which is what we all strive to get to. And it's always handy when you haven't had to go through about 5 different faults to get there. So here we are, boxer, water temperature's coming up now. So what we're looking for is just a nice steady pull. So we're just easing it up to the revs, we're through, so we're now up to 2.5, 3. Light throttle because we're still warming up. And this is where we were getting the problem. The sparks were moving around the leads and moving around in the wrong places at the wrong time. And you were getting this da-da-da, and now, a nice smooth pull. Just slow down again so we can go again. And what you find is when you load up an engine, when you've got your foot down, it increases the pressure in the cylinder, which means it's harder for the spark to jump through the spark plug gap, which means it'll go somewhere else. If it can't get to where it's going, it'll just go somewhere else. It'll go through a lead, it'll go through a coil, it'll go through a rotor arm, it'll go through a distributor, it'll go an easier route, which means that cylinder doesn't fire and you get the misfire. So you need it to work through all pressures in the cylinder. Because to be honest, when cylinders are high revving, the pressure is almost less. The most pressure is when you're fairly hard on the throttle at fairly slow speeds. So we're just coming around here. So if I squeeze this up a little bit now. I don't think there's a lot wrong with boxers. I love these. I think these are like Dinos on steroids. But for some reason they're not the most loved, and prices in the market, and they do take a lot of sorting out, and they are terrible on fuel. But when it sounds like this, What's not to like? I mean, that's pushing the head back. That's... And the other things we've done on this, it's got all new brake discs and pads, so we'll be bedding those in. So they're coming on nicely now. It's a bit warm in here, so I just put his air conditioning on. So, but the brakes are pulling up nicely, the engine's all settling down. So, we've had to dig really deep on this one to get this car right, but I said to the guy, I'm not going to give you your car back until it's right. I'm not going to give you back a Boxer that's got an intermittent misfire all over the place when it feels like it. So, I want to give you a Boxer that sounds like this. That's what Boxers should sound like. Nice, smooth pull, lovely noise. This has got a standard exhaust on this one, so fantastic. Air conditioning's working, which is pretty unusual for one of these. Fuel gauge not reading very much, lights flashing, but surprised you pay for feeling this good. So what we're also going to do on this, we're going to ask a lot of questions on how do I check my oil, what do I do hot testing. So we're going to, when we get back to the workshop, we'll do some other things of how to live with a Boxer and what you should look for. So I'm just going to sit back and enjoy the ride back down the bypass. But when there's no one around, you can do this. Pops or bangs. Again, if you get the mixtures out a little bit, you get a lot of popping and banging in the exhaust. There's no pops or bangs on this. Again, some cars do it more than others. Another question I got asked recently was about the black muck up the back of the cars, and unfortunately it is a sort of byproduct of carburettor cars. Carburettor cars don't meter the fuel anywhere near as accurately as the injection cars, so inherently they are a little bit overfueled, so you do tend to get the way the aerodynamics work on the car is the muck comes out the exhaust and gets sucked straight back onto the back of the car. 308s do it, these do it. Daytonas aren't so bad because of the design of the car. Dinos do it. So yes, you just have to wash it more often, but it's a small price to pay, I think. A bit of dirt up the back. But even now, just coming in second gear. The new system just gives a much bigger spark, a better spark, and a more controlled spark. Okay, so something I spoke about earlier is hot start. So this has been back in the workshop for 10 or 15 minutes now since we came on road test. So what happens is you go into your petrol station, you go somewhere, you stop, and then the thing doesn't start. Then you start pumping, flooding it, and then you've got no chance. So to start a hot Boxer, do the 1980s immobiliser, dip the clutch as always, run the pump. So what happens is everything evaporates, but you don't pump. You hold the throttle about halfway down and it'll just get air into the engine, and sometimes you'll have to crank it for say 20 or 30 seconds. When it's a really hot day and you're 30 degrees in the middle of summer, you'll just crank it and you just keep cranking. Don't pump, just keep cranking. Today's quite cold, so it'll probably start quite easily. Okay, so how to check the oil level on a Boxer. Now, the 365 is a wet sump engine, so all the oil is stored in a tank and you just dip it like a normal car. On a 512 and 512 injection, it's what's called a dry sump engine. So there's a big tank under here, similar to Porsches. We've spoken about these before. So the oil is stored in a big tank over here, and it is sucked from the engine, goes into the tank, and then drawn out of the tank, back into the engine, dribbles down to the sump again, and keeps going round. What you've got is, I think these are about 13 or so litres in these, so that's like nearly 3 gallon cans. You've got an awful lot of oil in these things, and it expands. So what will happen is when it's cold, if you fill it to here, when it gets hot and it expands, it'll be up here somewhere and it'll be overfilled. So when it's cold, you set it, people say, I've got nothing on the dipstick. It wants to be under minimum when it's cold, and literally on the bottom, because it will expand a good 3 inches or so. It'll go from here to the middle just on oil expansion. It's just the way it is. So what you don't want to do is dip the oil when it's cold and top it up. Some people say, well, you should do it when it's running. The trouble is, when it's running, it's all gurgling around the tank. And what happens is, you get a wrong reading. So if I dip this now when it's running, I'll put the dipstick in, do it up a little bit, bring it out. What I've got is oil right up here, because in reality what it's doing, the pumps are working, so the scavenge pumps are putting oil back in, and it's all gurgling and surging around, so you get a wrong reading. So you're all up to temperature, you've been up the road, it's all warm, you've got oil temperature and that going on. You put your dipstick back in, just locate it on the threads, give it a few turns, pull it back out again, and now you're going to get a true reading of the oil, because it's not all gurgling around and surging around. You can see on this one, we are just above minimum. So as long as it's between maximum and minimum, then if I stuck another ½ litre in this, which I might do, I'll just bring it up to say here. So at the moment we're here, you can see the bubbles. Anywhere between these two, sort of ideally in between the two, is the right place to be. If you leave it too long, what happens is the oil drains back out of the tank, back into the sump, so you've got to be reasonably quick, because it will drain back. You can see there, so second reading we are here, so we're there or thereabouts. But as I say, we've got 13 litres in this, so or 12.5, so it's only another ½ litre or so. So as long as we're in this area, there's plenty in the car. The only exceptions, I suppose, if you were going to do maybe a track day, you're going to drive this thing really hard. For normal A-road driving, it's absolutely fine. You might want to make sure you're nearer the minimum rather than the lower, just to get more oil in the system. But you certainly don't want to go over, because it'll all come out the top. So, but not many people track day these and drive them that hard. So that's how you do the oil on a Boxer. Okay, so another quick Ian tip on Boxers. You can imagine if this ever comes up on the road, it's like a great big sail and it's going to go over the top, and you can't get any of that lot. It's not going to exist. So always make sure your Boxer clam's shut. The way to shut a Boxer clam is to get to about here, about a foot or so off of the thing, and then just drop it. It sounds vicious, but it catches and it slams nicely. If you start pushing on things, this is all aluminium, you're going to dent it. And then you can just lift it gently and make sure the catch has gone in. And you come around this side and you can make sure that catch wants adjusting a bit, but it's locked in. There's a little safety catch in the middle that goes down. And the other thing with these is, the reason it goes up like this is you can see it in your rear view mirror. So when you sit in the car and you look in the mirror, and if you see this thing up, you know the hood's not locked down, then just lock that down like that. Just give it a tug and make sure the catches have locked in. So to open the front, first you've got to do is pull this little lever here. Now, these are only made out of soft aluminium. Some of them are steel. So there's two catches, so you want to hear two clicks. So when you pull it, 1, 2. Sometimes they pop together, but don't keep pulling it, because it will just snap it off. So you just pull it gently. And there's another one behind for the rear hood. Just ease it up gently. Now what you don't want to do is lift one side too much, because it's a great big aluminium panel. And if you try and lift from the middle and just lift it up a little bit, under this side is the safety catch. And then try and just lift it gently. So you've just got to get your thumbs on there. It's a bit heavy, but you can see the bracing of this is a big aluminium panel, and you've only got the bracing here. So if you pull one side, or one side hasn't released, you're going to bend the hood. Now, closing it, on any Ferrari, you always press where the catches are. So some like Dino's, the lock is in the middle, so you push it in the middle. On Boxers, you've got the locks are on top of each corner. So I've got one up there, one up there. So to bring it down, again, bring it down gently. And again, when you get to about a foot, just drop it. Let the weight of it do its own thing. Now, this side's gone in, that side hasn't. So the lock's going to be about here. So just get a cloth and just push with your palm of your hand just there. And if I come around this side, the catch is about here. So with the cloth, just press and you can see where we're going. And it's shut. You can hear it, feel it shut. Because if you push anywhere else, you're going to bend something. And that's that closed. So looking inside the car on electric, one of the weak points on the 80s Ferraris is the fuse boards. What they have is these porcelain fuses, and they get oxidisation here on these little brass contacts, and what happens then, it gets hot, then it melts the rivets here and these terminals come loose, and then that gives it even more of a high resistance joint, and then the whole lot fails. So the way to do it is either give them a little twist every time you get in the car, or when you use it, you can see that one's got hot and they've buckled. And denosing, just roll your fuses. If something doesn't work, give it a little twiddle and it'll probably start working again. Because you can see on that one, they've got an oxidisation on the fuse, and it means you don't get a good joint. So the ultimate thing is to replace the fuses. You can see up here we've put the modern fuses in, which have got the modern blade fuses in, and they've also got little LEDs, so when you do get a blown fuse, the little red light one comes on and tells you where it is. And we leave the client with a little bag of fuses in case he needs them. And we'll give a list of the original, what they all do, on a card, because you can't get the lids for these to work. The original lids don't fit. Okay, so as they say, here's some we prepared earlier. So these are some fuse boxes we've already changed, and this is an extreme case. So what you can see here is that the fuses started to overheat because the elements buckled, and then what's happened, it's warmed up the fitting of the fuse, and then it's gone down and actually melted the plastic. So you can see why old cars have electrical fires, because it's now melted all the plastic. And what someone's done previously in this one, then they've made it worse by soldering a piece of wire in between the two fuses and then overloading that fuse to run this. So that's why that one came off and went in the bin. So evolution of electronics, so that's why the design of fuse boxes changed from these Bakelite fuses to these blade fuses, and these are pretty much the ones that are used on all modern cars nowadays. It's a much better clip. The contacts are done two sides of the blade, and they just press in. So this is the sort of standard that everybody uses now, which is a much better connection. Okay, so I hope you've enjoyed this video. There's been a lot to this one. On the feedback, you're always asking for more technical stuff, so we've gone in quite deep on this one, especially for the boxer fans. So I hope you've enjoyed it, and we'll see you on the next one.